Today's lesson is a continuation of 30.3 trigonometry. We're going to take a look at the sine law. Using the trig ratios of sine, cosine, and tan, as well as Pythagoras' theorem, you can solve for missing sides, lengths, or angles of right triangles. But what happens if you know a missing measurement from a oblique triangle, a triangle without a right angle? Sine law can be used to solve for unknown sides or unknown angle measurements of oblique triangles in certain situations. The sine law states for that triangle ABC, sine A is divided by A. So the sine of this angle divided by this side is going to be equal to the sine of angle B divided by side B, and it's also equal to angle C, the sine of angle C, divided by the length of C. So we're going to take a look at a quick example. So sine of C is 110 over 3 is equal to the sine of B over 2. We can solve it and find out what sine B is. It can be used when you know two sides and the angle opposite one of them. This will allow you to solve for an angle opposite the other known side of the triangle. In this triangle above, you know sides B and C and angle C, and so you can solve for angle B. So this part is the only part we don't know. The sine law can also be used when you know two angles and the side opposite one of them. This will allow you to solve for the side opposite the other known angle. In the triangle above, you know angle C, angle B, and side B, and you're going to solve for C. So we know sine 110. We don't know side C, but we know the sine of B, which is 35 degrees, and we know side B. So the only unknown in this one is side C. So let's look at example 1. For triangle ABC, calculate the measure of B to 1 decimal place. So we have sine A divided by A equals sine B divided by B. Sine of A is 21 degrees. The side A is 41.8. Sine B is 58. And side B, we don't know. Now, before we start solving, we're just going to rearrange this equation to get B, the unknown, by itself. So we're going to cross multiply. We're going to get B sine 21 equals 41.8 sine of 58. To get B by itself, we divide by the value beside it, which is sine 21, divide by sine 21, and B equals 41.8 sine 58 divided by sine 21. Now, the beautiful part about doing it this way is that we can just put this part into your calculator all at once, and it will calculate the answer. So put in put in value 41.8 times sine 58, press equals, and then divide by sine of 21. Some calculators you won't need to press the equal sign, sometimes you will in the middle. So B equals 98.9 centimeters. Andrea is a machinist. She must program a laser cutter to make a triangle hole as part of a diamond-shaped grate she is making. The triangle is isosceles. Two of the legs are 8.4 centimeters in length, and the angles opposite each of these are 28 degrees. What must Andrea program the length of C to be? So we want to know what the length of C is going to be. So what is angle C? Right now we don't have an angle here, but we know a triangle is 180 degrees. So if you minus the two base angles of 28 degrees, you know that angle C is going to be 124. So sine A over A equals sine C over C. Plug in the numbers. Sine of A is 28, sine of 28 degrees over 8.4. And we have the sine of C is 124, and the side C we don't know. So we'll rearrange this by cross multiplying. C sine 28 equals 8.4 sine 124. Divide by sine 28. And you would put into your calculator 8.4 times sine 124 divided by sine 28. And the answer should be C is 14.8 centimeters. All right, I'd like you to practice Build Your Skills 262, question 3.